folks, we're back again with the 840 Ci drivetrain. What we're doing today is basically disassembling the motor from the gearbox, and we are then going to fit our little M8 countersunk screw to hold the hub back in onto the spline shaft of the Siemens motor, and we'll come back, do a few spins with just the motor itself. Now we'll couple it all back up and see if things want to spin up for us, and do a few more tests, so stay with us. Okay folks, this could turn into one of these found footage type of films, because basically what I've got here is I've got something that looks like the head from a mincing machine connected to a motor that's rated to spin at 10,000 RPM. It regens like a locomotive. So here we go. This is, by the way, I have installed a little set screw in here and pulled that hub in really tight, and it's eliminated I would say 99.9% of the remaining run out that I was previously experiencing. Now the inverter's punched up, and I've set the maximum frequency to 100 Hertz, which in the case of this motor is 3000 revolutions a minute of the meat grinder. So I have to keep a hand here on this part of the motor, because as I'm coming off the throttle, the regen kicks in and I'm dumping all of that kinetic energy back, and so it's trying to spin the motor chassis on me, which wouldn't be such a good thing. Better get that thermal box cover off there as well. So let's see what happens. I'm hoping the adapter plate would act as a kind of a scatter shield in the event that something untoward should occur. So hang on guys, here we go. That seriously regens. Right, let's hit it. Oh god! Ho! Ho! Right, I've dialed some of the regen parameters a little bit. I've now set Fmax to 200 Hertz, which is 6,000 revolutions per moment. Now this is definitely, this could be bad. Oh Jesus. Okay, let's, okay, I think we're okay here. Wow. Oh my God. Okay folks, I just removed the little screw from the center here, because I want to put some tread lock on it. This is the part. It's just a little countersunk head M8 by 25 Allen cap. So I'm going to, first of all, I'm going to clean off any of the oil, or as much of the oil residue as I can that's on there from storage and so on, just with a rag. Then I'm going to put some tread lock on there, and I have to tighten that in quite a bit because I need that countersunk section to pull the washer in tight to the motor shaft, because we've got very limited clearance inside this here for the torque converter nose. So I'm using a high strength red tread lock here, just put a nice bit of it on our treads. And let's get that guy in there. Now I could put this in here with an impact, but I don't necessarily want to go down that road at the minute. I'm just going to double check that we're still running nicely with that screw in there, which we are. I'm going to go ahead and tighten it in. Like so. It's running very nicely. Just get my bald head in your way there for a second and see that I'm fairly flush in there. I might just go another small bit. I think that's us pretty much where we want to be in there now. That's pretty good. So, next part of the operation will be to individually take out each of these screws here. The original flex plate mounting bolts. And we're going to put those back in with tread lock and the impact wrench. First of our screws. Going to come along some of our tread lock on there. Not a huge amount, that's just enough to so they don't move. Start it by hand, and what I'll probably do as well is just get a little black marker here. And I'll mark each stud, or each bolt I should say, as they're tightened in. Start one on. And just make sure the threads are engaged by hand. Hit it with the impact. Mark it off as tightened. I'm not going to subject you guys to the whole 9 of them, so we'll come back when we're finished. Okay folks, that is us. That's our flex plate and hub assembly, fully mounted onto the Siemens motor. So what we're really going to do now is just to put the whole assembly back together with the gearbox. I'm not going to expose you guys to that one. You've already seen me doing that, so shouldn't be a problem. We're going to get it back together and then we'll do a few test spins. Then we're going to wrap this up. Okay folks, I went ahead and I assembled back up, reinstalled the torque converter bolts with some Loctite on them, I'm very pleased to report that I can now very easily spin the whole torque converter flex plate assembly with just one finger into the access hole here. The whole thing is really smooth and turns over very nicely. I've got the inverter punched up. I have been trying some experimental firmware here that had a motor idle function on it, and I was hoping to get that to run, but it looks like we've a little bit of a glitch in there. It's just not commanding the contactor to close, so it is trying to idle the motor, but it's just burning up my pre-charge resistor, so it's just probably some little unintended consequence in there on the code that we'll need to get sorted out. But in the meantime, we can certainly run just using the manual throttle. So I'm set to a maximum of 50 Hertz, so which is around 1500 RPM, a little bit less than that. And we're in park, and let's just do a few runs. This thing is sounding very nice indeed, I have to say. So here we go. Let me see if I can get that. Or at least we would be if I'd switched on the inverter. Sorry guys. I rigged up some push button switches and that here to make life a little bit easier as well. So right, take two. Okay, we're at about 400 revs right now. Let's ease it up a notch. Revs. And there's 600 revs. So that'll be around about idle speed that I want, or over a little bit there now. But just putting my hand on the motor, there is absolutely not. I wouldn't know that that was actually running if I couldn't hear it and see it. It's absolutely smooth as silk. So let's take her up a notch. There's 1000 RPM. Again, not a whisper out of it. Our oil temperature is starting to come up. There's 1200 revs. Graphing this on the computer right away. I'm getting data from the inverter. Going up to 1400 revs. These little pulsations are just parameters in the inverter that when it reaches the set point, it's a little bit of a... Let's see if we can go up to 1500 now. A little bit of a off the whisker there. Our temperature's coming up nicely. We're at 1400 revs in Just let her stop. Okay. So once we get our idle function running, we should be able to do a lot more. So there's park, reverse, neutral, drive, and first gear. So let's go for a bit of a gear changing run. See how she likes that. Okay, here we go. First gear's in. Let's get up to around 600 or 700 revs here of course. And 600 RPM now, first gear. There's second gear. About 700 revs now, that's second gear. Third, there's third gear, and about 700-800 RPM running on in third gear. Fourth. Do have some tweaking on the code to do around this stuff, alright. Interesting to watch the RPM graphs as the gears change. I think this one mightn't be tuned in just right. Let's go for fifth. Yeah, there's definitely a bit of an overlap on the clutches there going into fifth. But the RPM graphs will be quite useful actually for tuning out all of these parameter issues. There's top gear, so let's rev her up a little bit. Okay, so selector's in reverse. Here we go. Tearing around in reverse. Oh, okay folks, I think you guys get the idea. We've got some success here. We have a good bit more to do and get the motor idle function working and so on. But we got some great progress here on this drivetrain, and stay with us and we'll get the inverter working and we get it all made up here on the bench and be running a lot more testing. So Thanks to everyone that's sent me supportive messages, and we'll see you all soon. Thanks guys.